Hi, welcome back to grade 9 physics. I hope you went through the last day's topic, which was distance and displacement. So let's start today's lesson with recapping the concept we have learned in the last lesson. Just instead of just going through the topics again, I am going to solve some questions related to that topic, so you can it will help you to recall the concept, and you can do some practice related to that one. Okay, so look at the first question. This is the first exercise in your textbook. An object has moved through a distance. Can it have a zero displacement? If yes, support your answer with an example. Last day we discussed that an object can have zero displacement, but the distance will never become equal to zero for a moving object. Okay, so they are asking for an example. You can take any closed path. Here I am going to take a path in the form of a square, rectangle, or something like that. So I am taking a path like this. In this path, I label the path as A, B, C, D. Suppose he is starting from A and he takes a round and comes back to A. So his initial point and final point. This is he is starting from A, and after taking a turn, he is coming back to A. He comes back to A. So his initial point and final point is zero. So in this particular case, his displacement is zero. Okay, so you can tell this as an example. A man moving along a square or rectangular path. Let A be his initial point. After completing one round, he comes back to A. So the total displacement is zero. But as you can see, his total distance is not zero, but displacement is zero. You can take example of a circular path even. Okay, when he completes uh, one round around this circular path, his displacement is zero. Okay, so any closed shape like this you can take, and you make sure that the initial point and final point is the same, so the displacement becomes zero. Now let's move to the second question. A farmer, this is the second question. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. Okay, so that's the example given over here. So it's a square field, and the side length of the side is given over here as in the case of previous example. So this is a square field like this. Okay, A, B, C, D. Okay, so he is taking 40 seconds for completing one round. That means he is starting from A. For coming back to A, he is taking 40 seconds. Okay, what will be the magnitude of displacement of the farmer at the end of 2 minutes and 20 seconds? So you have to calculate what is his displacement after 2 minutes 20 seconds. Okay, 2 minutes 20 seconds. First we have to convert both of them into seconds. So 2 minutes, we know it is 120 second. 2 minutes is 120 second, and again 20 second here. So together 140 seconds. So we have to find what is the position of the person after 140 seconds. So he started from here. He takes one round. For one round he is taking, for one round he is taking 40 seconds. Okay, that means he is starting from A and he comes back to A. For two round he will take 80 seconds. That means after two round he again take one more round, he comes back to A. At the end of third round, that means 120 second. After 120 second, again he will come back to the point A. So after 120 second, his position is at A. Now we have to find what 140 second. What will be his position after 140 second? So for covering each side of this square, he is taking 10 seconds. Okay, because each side is 10 meter. For 10 meter means together it will be 40 meter. Each together the whole side will be 40 meter. So for each side he is taking 10 seconds. Okay, so after the third round, that means after finishing 120 second, his position is A. After then 120 second, then after now his position is A. After 10 seconds, he will come to B. That means 130 second from A, he will reach to B. Then he will move along this side. At the end of 140 second, his position is C. Okay. So his initial position was A, his final position is C. Okay. Now, how we will calculate the displacement? This is his initial position. This is his final position. So you draw a straight line connecting these 2 points. Okay. So when you draw a straight line, it will come as the diagonal of this square. We know that the diagonal of this square, suppose this side is 10, this will be how much? 10 root 2. Okay, so 10 root 2 meter is the answer for this question. If you want, you can multiply with the value of root 2 and write the answer. Okay, so he started his journey from A. He is taking 40 seconds for completing each round. So for completing 3 rounds, he is taking 120 seconds. We have to find out what is his position at the end of 140 seconds. So 120 second A, then he is taking 10 seconds for completing each side. So 140 means he will be at this side. Okay, so anyway, he started his journey from A. So his initial position is A, final position is C. Then find the displacement means you have to find the straight distance between, that will come as the diagonal of this. Okay, I think you understood that one. Which of the following is true for displacement? That is the third question. It cannot be 0. It can be 0. So this statement is false. Okay, it can be 0. Its magnitude is greater than the distance traveled by the object. This statement is also false. I told it can be equal to displacement, but distance and the displacement can be equal, but displacement never will become more than distance. Always distance will be higher than displacement. Okay, in a straight line motion, both of them can be the same. So these questions are related to the topic that we have discussed in the last class. Now I am going to the new portions. Okay, so we were talking about a set of physical quantities which are needed for explaining motion. So the first set of physical quantities were distance and displacement. So we actually we discussed what are the difference between distance and displacement. Okay, now we are going to the new set of physical quantities which are needed for explaining motion. Okay, let's move to the next topic. Okay, before moving to the next topic, there is a term given in the textbook: uniform motion and non-uniform motion. You know what is the meaning of the word uniform? Uniform means something is equal. In the school and all, we are wearing uniform means we should, like, for creating that sense of equality, we are wearing that uniform. So uniform means something is equal there. Okay, for example, suppose an object is moving from A to B. Okay, I have divided the journey into 3 sections. Okay, so here this is his first stop, second stop, third stop, and this is his last one. If he covers, this is intervals. Okay, so if he covers equal distance in equal intervals of time, it is said to be in uniform motion. For example, suppose he is starting his journey from 1, and suppose the next point stop is this one. Okay, this is his first starting point, this is his first stop. Okay, so the distance between these 2 points is 10 meter. For suppose he is taking suppose he is taking a 5 minutes or something to cover this 10 minutes, and again the next 10 minutes he is covering in 5 minutes, and next 10 minutes he is covering in 5 minutes. It is said to be uniform motion. That means he is covering equal distance in equal intervals of time. Here the intervals of time is 5 minutes. In each 5 minutes he is covering 10 minutes. So the object is said to be in uniform motion. But as we know that uniform motions are very uncommon in our daily life, because most of the motion we see around us are non-uniform. Okay, because they cover unequal distance in different time intervals. Okay, most of the time, suppose you are starting a car, in the beginning the car will cover very in the beginning it will cover very few distance, but gradually when its speed increases it can cover more distance. Okay, so you can, the time, the definition is also given in the textbook as the object covers equal distance in equal intervals of time, it is said to be uniform motion. But most of the time in this type of motion you can see that the time interval will be very small. Okay, the time interval may be small or big. In your daily life we cannot see this type of, so just you should know what you mean, like what's the meaning of the term uniform motion. Suppose in a question they are telling that it's a body is moving, the body is undergoing a uniform motion, should understand that it is covering equal distance in equal intervals of time. Okay, now now we will move to the next one, which is how we will what are the next set of physical quantities we need for describing motion. Okay, what are the new sets of physical quantities, like distance and displacement? What are the next things? Okay, the next set of physical quantity is speed and velocity. Okay, the term speed is very familiar for you. You have learned in your lower classes. You know what is the idea of speed. You know how to calculate speed. Speed tells how fast or how slow an object moves. Okay. And the equation for speed is total distance covered by the object divided by total time. How much time is, or simply you can tell that it is distance divided by time. Okay, so see, for calculating speed you should know what is the distance covered by the object and how much is the time taken for covering that particular distance. Okay, and the unit of speed is like it is meter. Unit of distance can be meter, and it is meter per second. It can be centimeter per second. It can be meter per minute. It can be kilometer per hour. Normally in cars and all we are using kilometer per hour. So these are the different units of speed, but the SI unit of speed is meter per second. That is the standard unit we are using in physics, which is meter per second. Okay, suppose I am telling that the speed of an object is 10 meter per second. What is the meaning of that statement? In 1 second, the object covers 10 meter. Okay, so it is the rate at which the object covers the distance. How much distance it will cover in certain interval of time. Here 10 meter per second means in 1 second it will cover 10 meter. You know the speed of light is 3 into 10 raised to 8 meter per second. Okay, that means in 1 second light can travel 3 into 10 raised to 8 meter. That means after 3 you have to keep 8 zeros. Okay, so that much high is the speed of, that much fast is light. Okay, so speed tell how fast or how slow one object moves. It is the distance covered by an object in a specific interval of time. It's the same way in speed. We know in our daily life situations, speed will not be a constant. Its magnitude will be changing all the time. Because suppose you are moving in a car, in the beginning the car will be having very low speed. In between you will increase the speed. Suppose we will when you are facing a traffic or something like that, speed again will change. So speed is not a constant value. Speed can change. Okay, but when it comes to uniform motion, where the object covers equal distance in equal intervals of time, when the object covers equal distance in equal intervals of time, the speed becomes a constant. Okay, in uniform motion, speed is constant. Okay, because all the time the object will be covering same distance, same time, same distance, same time. So whenever you are dividing, you will get the same. Look at this equation, average speed. Why we are taking average speed? Because as I told, normally the speed will not be a constant. The value of speed will be changing. So that's why we are using the term average speed. Average speed is equal to total distance traveled divided by total time taken. And in physics, S is the letter we are using for representing distance. Okay, actually it is, you can find out how, why it is S, not D, from where it got the letter S. Okay, so V is representing speed. V is equal to S by T. That means don't feel like S is speed. Here S stands for distance. Okay. So speed equal to distance divided by time. If it is average speed, you are supposed to take total distance divided by total time. Okay. So I think that idea of speed is very clear for you. Let's see one example in your textbook. Okay, it is already worked out here, so just have a look at that one. Look at this question. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed? Okay, actually it is covering same distance. Both time it is covering same distance of 16 meter. But the problem is that in the beginning it is taking 4 seconds and in the second section it is taking 2 seconds. So can you tell where the speed of the object will be more? You can see that this time, because he is covering 16 meter in just 2 seconds. Okay, what is the average speed of the object? How we will calculate average speed? Our equation is total distance divided by total time. Okay, so total distance is how much? 16 plus 16, that is 32, divided by time 4 plus 2, which is 6. Okay, so how much will be the answer? It is already, the answer is already given in your textbook. 32 divided by 6, which is 5.33 meter per second. Okay, 5.33 meter per second. Okay, whenever you are doing numerical, don't forget to keep the unit. Always try to keep the unit. Don't forget that one. Okay, because whenever we are evaluating paper, we will give mark for this unit. Okay, so 5.33 meter per second. 5.33 is what? 5.33 is the magnitude. This is the average speed of the object. Okay, so speed is when you are telling the number, it is 10 meter per second or 5.33 meter per second, that is complete. Okay, suppose so speed is clear. Now we are moving to the next quantity, which is velocity. Okay, I think velocity is not that we are not using in our day-to-day life. Velocity is a pure scientific word, I think so. Okay, so let's have a look at what is the meaning of the word velocity. We are going to the next, a comparatively new physical quantity, which is velocity. If you are asking what is velocity, in a very few words we can tell, speed with direction is called velocity. Actually, velocity and speed are relatively very similar physical quantities, but they have a very small difference between each other, as we explained in the case of distance, how distance and displacement is different. The same way some changes are there between speed and velocity. Okay, now suppose we are telling that a speed of the object is 10 meter per second. Okay, so that means the object's position can be 10 meter away from 10 meter away in any direction, 10 meter per second. The object is moving in 10 meter per second. Suppose somebody is asking you, what is where is your school? You are just telling it is just 5 kilometers away from my house. But actually that is not 5 kilometer away from your place means it can be in any direction. So in order to specify the location, if you are adding, suppose 5 kilometer, you move 5 kilometer towards north, or 5 kilometer towards south, or right side, left side, like that. If you are adding some direction to that one, it is easy for you to locate the place accurately. Okay, the velocity is also a quantity like that. In speed, you are just telling that 10 meter per second. You are not giving any clue about the direction of the object. I am telling that the car was moving 10 meter per second in north direction, or the wind was blowing in the north direction with this much speed. You, when they are telecasting weather and all, you can hear the wind is blowing in this particular direction. They will give you some coordinates and all. Okay, so when you are adding a direction to speed, it becomes velocity. Okay, why we need velocity? Because it makes the quantity more accurate, or you can locate the position more precisely. That is why we are using velocity. Normally we don't use this one. When, as I told, in the case of like gas molecules, randomly they are changing their direction, we can use velocity. Okay, so velocity is speed with direction. Okay, so velocity is speed with direction. So it is something similar to displacement. In speed is distance divided by time, but velocity is displacement divided by time. Okay, it is displacement divided by time. Why displacement? Because when we were talking about displacement, in that case also we were giving importance to the direction. Distance, in a distance, suppose the object is moving 10 meter towards north, that means it became displacement. So distance with direction is called displacement. So when in order to find velocity, it is not distance by time, it is displacement divided by time. When I discussed displacement, I told you that displacement depends upon initial and final position of the object. The same way, velocity also depends upon the initial velocity and the final velocity. Okay, so in the textbook, you can see how they have written the equation. In the case of, look, average velocity. In average velocity, we are taking initial velocity and final velocity. That means we are taking the average of the velocity. So initial velocity plus final velocity divided by 2 will give you average velocity. But average speed was total distance divided by total time. Okay. So this is the difference between, so velocity is like this, displacement time. If it is average velocity, how we will calculate? Average velocity is equal to, we are not adding all the velocities together. We are taking initial velocity plus final velocity divided by 2. Okay, initial velocity is represented by the term, we have letters for each one. Okay, initial velocity is represented by, we have initial velocity is represented by u, final velocity represented by v, Okay, so how we will write our equation? Average velocity is equal to initial velocity plus final velocity divided by 2. So the average we are taking. Okay, we are not worried about what is happening in between. We just want initial value and final value. So velocity average is equal to u plus v divided by 2. U stands for what was the initial velocity. That means suppose an object is at rest. Suppose it is rest. In the beginning, if it is at rest, u is equal to 0. Okay, like that you have to find out what is its initial, what is its final, add them, divided by 2, you will get velocity. So this is what velocity means. Speed with the direction. That means when you are telling an object is moving 10 meter per second towards north, it gives velocity. Okay, 10 meter per second is magnitude. If it is magnitude alone, it is speed. If you are adding direction to that one, it will become velocity. Okay, so when the question is differentiate between speed and velocity, you can write what is speed, what is velocity. You can write the equation. You can write speed is not having only magnitude, velocity is having both magnitude and direction. The same way, velocity can be zero, because we know that displacement can be zero. If it is moving in a closed path, velocity closed path, what will happen? Suppose the object is moving in a closed path like this. Okay, we know that here displacement is zero. Here displacement is zero. When displacement is zero, velocity becomes zero. Okay, and the same way displacement can be negative. We learned how displacement become negative in the last class. The same way velocity can also be negative. Okay, speed when it is moving never becomes equal to zero, not equal to zero, always positive. Velocity can be zero, positive and negative. Okay, so this is the difference between speed and velocity. I hope you understood the topic. Okay, I'm following the same way as it is given in your textbook, so it will be helpful for you when you are doing solving numericals and all. So this is all for today. Please go through the video. You have any comments, you can, if you have any comments, any suggestions, any doubt, you can leave a message down. The next class I will take the numericals related to this one. Okay, now thanks, bye, take care.